Welcome to Management and Maintenance of Secure Networks. In this module, you'll gain insights into the ongoing processes and strategies for keeping network environments secure, reliable, and robust. We will cover the best practices for network management, including monitoring, performance tuning, and proactive security measures like patch management and vulnerability assessments. This week's content will help you understand the tools and techniques professionals use to anticipate and mitigate risks, ensuring network infrastructure remains resilient against potential threats. This module consists of the following 5 sections. Section 1, Introduction to Network Management. In this first section, we delve into the fundamentals of network management, focusing on processes, tools, and duties of network managers. We'll cover monitoring performance, troubleshooting, and strategic updates. Section 2, Security Monitoring and Analysis. Section 2 explores security monitoring and analysis, focusing on detecting and responding to security threats using tools like IDS and SIEM systems. It emphasizes continuous surveillance and analytical skills for network integrity and resilience against cyber threats. Section 3, Patch Management. Section 3 delves into a crucial security practice that involves regular software updates to fix vulnerabilities. It covers challenges, best practices, patch assessment, threat severity prioritization, and deployment strategies. It also examines automated tools for timely updates. Section 4, Security Policy Enforcement. Section 4 discusses the implementation and maintenance of security policies within a network, emphasizing the importance of comprehensive policies for protecting information and resources. It covers enforcement tools like firewalls, access control lists, security protocols, and ongoing training and audits. Section 5, Incident Response and Recovery. Section 5 addresses network security incidents. It covers preparing, identifying, responding to, and recovering from incidents, creating response plans, the roles of response teams, communication, and recovery plans. Mastering these skills can minimize incident impact and restore operations efficiently. In Section 1, Introduction to Network Management, students are introduced to the crucial discipline of overseeing and maintaining the operational integrity of network infrastructures. This foundational segment will guide you through the core concepts of network design, implementation, monitoring, and control. You'll learn about the key tools and technologies network professionals use to ensure networks run smoothly and securely. Network management encompasses a broad set of procedures and operations to administer, maintain, and optimize a computer network. This field is pivotal for ensuring the reliability and performance of both the hardware and software that make up a network. Here's a look into the components of network management. Network administration. This involves the tasks associated with managing network resources like user accounts, permissions, and other housekeeping processes. Network operation. This area focuses on ensuring that network services are up and running smoothly. It includes monitoring network activity and ensuring the infrastructure can support current and future demands. Network maintenance involves tasks to keep the network at optimal performance levels, such as updating hardware and software, performing repairs, and conducting preventive measures to avoid system outages. Network provisioning. This involves enabling the configuration of network resources to support a given service. For instance, this could be setting up the network to handle a new application's data traffic. The goal of network management is to maintain high-quality network performance, ensuring the smooth and secure data transmission while staying adaptable to the organization's and its users' evolving needs. Network management and security are two interrelated disciplines within the networking field that ensure computer networks' effective and safe operation. Network management, a crucial discipline, is dedicated to network systems maintenance, administration, and operation. It meticulously handles the network's technical aspects, such as performance monitoring, configuration, fault analysis, and troubleshooting. Its primary objective is to uphold the network's overall health and functionality, ensuring network resources are readily available to users and applications when required, thereby underscoring the importance of your role in this process. Network security, on the other hand, specifically focuses on protecting the network and its data from unauthorized access, attacks, misuse, or theft. This involves implementing various security measures, such as firewalls, intrusion detection systems, encryption, access controls, and security policies. The relationship between network management and network security is symbiotic. Proactive monitoring. A key aspect of network management is monitoring network performance. This not only ensures the network's smooth operation, but also plays a crucial role in detecting unusual patterns or traffic that could signify a security threat. This proactive approach fosters vigilance and preparedness in your role, underlining the importance of staying ahead of potential security issues. Policy implementation and enforcement. Network management includes enforcing policies that often have security implications. For example, access controls and user privileges managed by network administrators are key to securing sensitive resources. Configuration management. Network management ensures all devices are correctly configured, including implementing necessary security controls. Secure configurations are not just a part, but a foundational aspect of network security. This underscores the crucial role of network management in maintaining a secure network, further reinforcing the symbiotic relationship between the two disciplines. Incident response. When network security identifies a threat, it is the job of network management to respond to the incident by isolating affected systems, reconfiguring networks, and restoring services to a secure state. Maintenance and patching. Regular updates and maintenance activities, which fall under network management, are crucial for security. Keeping systems patched and up to date is one of the most effective security measures against vulnerabilities. Security tools deployment. Network security tools must be effectively managed and monitored, a function of network management. Compliance and auditing. These are not just routine tasks, but critical responsibilities of network management. They involve auditing and ensuring compliance with security policies and external regulations, tasks that carry significant weight in maintaining the security of our network infrastructure. While network management sets the stage for a stable and efficient network infrastructure, network security focuses on defending this infrastructure from threats. Both areas must work together to ensure that a network is not only operational, but also secure from threats both internal and external. This integrated approach is vital for the resilience and reliability of IT services within an organization. Managing secure networks is a complex task that involves balancing accessibility with security, and it comes with several key challenges. Complexity of networks. Modern networks are vast and complex, comprising various devices and services. Managing such networks requires detailed understanding and control over every component. Adapting to rapid technological changes. The swift pace of technological advancement means new vulnerabilities are constantly emerging. To address this, network management tools must continually evolve to keep up with the latest threats and innovations. Challenges in integrating diverse devices. With the proliferation of IoT devices and BYOD, bring your own device policies, networks are more diverse than ever. This diversity poses significant challenges, complicating security and management. Resource constraints. Organizations often need more support in terms of budget, skilled personnel, and time, which can hinder effective network management and security. Compliance and regulatory challenges. Ensuring network management practices comply with industry standards and regulations can be difficult, especially with constantly changing laws. Scale and scope of cyber threats. The number and variety of cyber threats are growing, making it harder to maintain a secure network. This includes everything from malware to sophisticated nation-state attacks. Insider threats. Not all threats come from outside the organization. Managing access to prevent data leaks or misuse by internal users is a constant challenge. Visibility and monitoring. Gaining full visibility into network traffic and accurately monitoring for anomalies is challenging, but essential for security. Proactive versus reactive measures. Striking a balance between proactive measures and reactive incident response is a tightrope walk. However, the necessity of proactive measures cannot be overstated, as they play a crucial role in preventing security breaches. Performance and security. Implementing stringent security measures can often impact network performance, which can be a significant challenge in network management. Remote workforce. The complexity of managing secure access to network resources for a remote workforce without compromising security has significantly increased. This challenge demands our attention and innovative solutions. Patch management. Timely patching is crucial for security. However, deploying patches without disrupting services and ensuring compatibility poses challenges. Security awareness and training. Ensuring all users are educated about security best practices is a significant and ongoing challenge. Data privacy. Protecting data privacy involves managing networks to secure them from intrusion and handling data responsibly. Addressing these challenges requires a strategic approach to network management that integrates robust security practices, ongoing education and training, investment in tools and technologies, and an adaptive security posture that can respond to evolving threats. Security monitoring and analysis are critical components of an organization's cybersecurity strategy. They involve continuously observing the IT environment to detect, analyze, and respond to potential security threats and vulnerabilities. Effective security monitoring and analysis help organizations maintain network visibility, identify anomalous activities, and mitigate risks before they can cause significant damage. Here's an overview of the key aspects involved in security monitoring and analysis. 1. Data collection. Collect and manage logs from various sources, such as servers, network devices, and security appliances. Network traffic analysis. Use tools to monitor and analyze network traffic patterns to detect anomalies that may indicate a security incident. 2. Threat detection. Signature-based detection. Utilize known patterns or signatures of malicious activity to identify threats. Anomaly-based detection. Employ machine learning and statistical modeling to detect deviations from normal behavior that could indicate a threat. Behavioral analysis. Monitor the behavior of users and entities to identify actions that deviate from established patterns. 3. Incident analysis. Event correlation. Aggregate and correlate events from different data sources to identify potential security incidents. Root cause analysis. Determine the source and method of attack to understand how the breach occurred and how to prevent similar incidents. 4. Alerting and reporting. Implement real-time alerting mechanisms to notify security personnel immediately upon detection of potential threats. Dashboards and visualization. For quick assessment and decision-making, use dashboards to provide a visual overview of security status and events. Regular reporting. Generate reports for various stakeholders to provide updates on security posture and incidents. 5. Response and mitigation. Automated response. Deploy systems capable of automatically responding to certain threats to reduce response time. Incident response planning. Integrate monitoring and analysis with incident response plans to ensure quick and effective action when a security incident is confirmed. 6. Continuous improvement. Feedback loop. Use insights from monitoring and analysis to refine and improve security measures continually. Tuning and optimization. Review and adjust the settings of security tools regularly to enhance detection capabilities and reduce false positives. Many tools and technologies safeguard networks, systems, and data in cybersecurity and IT management. Here's an overview of some key categories and examples of the tools and technologies used. Security Information and Event Management, SIEM. This combination of Security Information Management, SIM, and Security Event Management, SEM, provides real-time analysis of security alerts generated by applications and network hardware. Intrusion Detection Systems, IDS/Intrusion Prevention Systems, IPS, monitor network or system activities for malicious or policy violations. Endpoint Detection and Response, EDR, tools are focused on monitoring endpoint devices and responding to threats they detect. Network Detection and Response, NDR, solutions focusing on network traffic to detect and respond to threats. Threat intelligence is not just about collecting and analyzing information. It's a dynamic process that involves staying one step ahead of potential or current attacks that threaten an organization's or its assets' security. A mature threat intelligence capability is not just important, it's vital for organizations to proactively identify, assess, and mitigate cyber threats. Let's dive into the key components of threat intelligence and how it is used in cybersecurity. 1. Strategic threat intelligence provides insights into the broader trends and motivations behind cyber threats. Helps senior management understand cybersecurity risks in the context of business risk management. Often derived from a broad analysis of trends in the cyber landscape, geopolitical events, and industry-specific threats. 2. Tactical threat intelligence focuses on the tactics, techniques, and procedures TTP's threat actors use. Helps cybersecurity teams understand how threats are carried out and what vulnerabilities are being exploited. Useful for improving defensive strategies and security controls. 3. Operational threat intelligence involves detailed information about specific attacks or campaigns. Provides real-time actionable intelligence to respond to active threats. Often includes indicators of compromise, EOCS, such as specific malware signatures, IP addresses, or URLs used in attacks. 4. Technical threat intelligence, most technical form of intelligence. Involves data points like hashes, malicious IP addresses, URLs, and domain names. Security tools and personnel are used to set up defenses and respond to immediate threats. Patch management is a crucial aspect of maintaining the security and functionality of software and systems within an organization. It involves the acquisition, testing, and installation of updates to software, commonly known as patches, to correct security vulnerabilities, fix bugs, and enhance functionality. Effective patch management is vital to protecting systems against known vulnerabilities that could be exploited by cyber attackers. The patch management lifecycle is a systematic approach to managing updates for software and systems within an organization. It involves several stages, each crucial for ensuring the secure, efficient, and effective application of patches. The lifecycle ensures that vulnerabilities are addressed quickly and consistently, minimizing the risk of security breaches and system downtime. Challenges in patch management. Resource constraints. Limited IT staff and time can hinder the regular application of patches. Complex environments. Diverse and complex IT environments can complicate the patch management process. Patch availability. Sometimes patches are not immediately available from vendors, especially for less common software or older systems. Best practices for patch management. Automate processes. Automate automation to streamline patch management tasks, reducing the workload on IT staff and minimizing human error. Regular updates. Maintain a regular schedule for checking and applying patches to ensure timely protection against threats. Educate and train. Train IT staff on best practices in patch management and keep them informed about emerging threats. Vulnerability management integration. Integrate patch management with broader vulnerability management processes to enhance overall security posture. Effective patch management not only secures systems against potential threats, but also ensures that software continues to run efficiently and effectively, safeguarding an organization's technological assets and supporting its broader security strategies. Security policy enforcement is a critical aspect of maintaining an organization's overall cybersecurity posture. It involves implementing and enforcing policies designed to protect the integrity, confidentiality, and availability of data and IT assets. Effective enforcement ensures that security measures are consistently applied and that deviations or non-compliance are promptly addressed. Here are the key components of effective security policy enforcement. Development of comprehensive security policies, scope, and objectives. Define what the policies cover and the goals they aim to achieve. Specificity and clarity. Write clear, unambiguous policies that specify acceptable and unacceptable behaviors, security procedures, and resource use. Alignment with regulations. Ensure policies comply with relevant legal, regulatory, and industry standards to avoid compliance issues. Communication and training. Employee awareness. Regularly communicate policies to all employees and provide training to ensure they understand their responsibilities. Continuous education. Offer ongoing security awareness training and update training materials to reflect new threats and policy updates. Implementation of security measures, technical controls. Deploy appropriate technical controls, such as firewalls, intrusion detection systems, and encryption, to enforce policies automatically. Administrative controls. Implement procedures and guidelines that support the enforcement of policies through administrative actions. Monitoring and auditing. Continuous monitoring. Use security tools to monitor IT environments and detect policy violations or suspicious activities. Regular audits. Conduct regular audits to assess compliance with security policies and the effectiveness of implemented controls. Enforcement mechanisms. Incident response. Have a clear procedure for handling policy violations, including escalation paths and disciplinary actions. Automated enforcement. Where possible, use automated systems to enforce policies, such as software that restricts the installation of unauthorized applications. Response and remediation. Immediate action. Quickly address any breaches or violations to minimize damage. Feedback loop. Use incidents as feedback to improve policies and training. Review and update. Periodic reviews. Review and revise security policies regularly to ensure they remain relevant and effective against evolving threats. Stakeholder input. Include feedback from various stakeholders to ensure policies are practical and comprehensive. Implementation tips. Use of technology. Leverage technology to automate policy enforcement as much as possible, reducing the reliance on manual processes. Cultural integration. Foster a security-conscious culture where security policies are integral to everyday business processes. Management support. Ensure strong support from senior management to give security policies the necessary authority and visibility within the organization. By systematically enforcing security policies, organizations can significantly reduce their vulnerability to cyber threats and protect their critical assets more effectively. This approach safeguards information and systems and reinforces the organization's commitment to security at every level. Incident response and recovery are critical components of an organization's overall cybersecurity strategy. These processes ensure an organization can quickly manage and recover from security incidents to minimize their impact on business operations. Here's an overview of the key aspects of incident response and recovery. Key elements of incident response planning. 1. Preparation. Developing policies and procedures that define what constitutes an incident. Establishing an incident response team, IRT, with clearly defined roles and responsibilities. Training team members and other relevant staff on their roles during an incident. Ensuring all necessary tools and resources are available and accessible. 2. Identification. Implementing monitoring tools and techniques to detect potential security incidents. Establishing clear criteria for what triggers an incident response. Regularly updating and tuning detection systems to adapt to new threats. 3. Containment. Developing short-term and long-term containment strategies for different types of incidents. Isolating affected systems to prevent the spread of an incident. Implementing backup and redundancy procedures to maintain business operations during incident handling. 4. Eradication. Identify the root cause of the incident and remove affected components. Updating security measures and patching vulnerabilities to prevent reoccurrence. Cleaning and restoring systems to their operational state. 5. Recovery. Restoring systems and data from backups. Monitoring the systems for signs of weaknesses that could be exploited again. Gradually reintroducing systems into the production environment to ensure no remnants of the threat remain. 6. Lessons learned. Conducting a post-incident review to determine what was done effectively and what could be improved. Documenting the incident's details, response effectiveness, and remedial actions taken. Updating the incident response plan based on feedback and lessons learned to improve future responses. Implementation tips. Communication. Establish clear communication channels both internally and externally. As appropriate, inform stakeholders and, if necessary, customers about the incident. Legal considerations. Understand and comply with legal and regulatory requirements regarding incident reporting and data breaches. Partnerships. Collaborate with external experts, law enforcement, and other relevant entities when needed. Continuous improvement. Regularly test the incident response plan through drills and simulations to ensure its effectiveness and make necessary adjustments. By following these stages and maintaining a proactive stance on continuous improvement, organizations can build resilience against incidents and protect their assets, reputation, and stakeholders. Recovery strategies and disaster recovery planning are essential components of risk management for businesses, organizations, and even at the level of personal data protection. These strategies are designed to ensure that an entity can continue to function or quickly resume its critical functions following a disruptive event, such as a natural disaster, cyber attack, or equipment failure. Here's an overview of the key aspects. Recovery strategies. Data backup. Regular backups of data are fundamental. These can be on-site, off-site, or cloud-based, ensuring that data can be recovered and restored quickly. Redundancy. Implementing redundant systems, such as having multiple data centers, can ensure that if one system fails, others can take over without disrupting services. Failover mechanisms. Automatic failover to a secondary system or network can help maintain service continuity without manual intervention in case of a system failure. High availability systems. Designing systems and infrastructure to be always available and operational, even when parts of it are not functioning, typically through the use of clusters or mirrored environments. Disaster recovery planning, DRP. Risk assessment. The first step in DRP is identifying potential threats and vulnerabilities that could impact operations. This involves analyzing the likelihood and impact of different types of disruptions. Business Impact Analysis, BIA. This helps identify and prioritize critical business functions and processes, and the resources required to support them. Plan development. Developing the DRP involves outlining the strategies for response and recovery, defining roles and responsibilities, and establishing communication protocols. Testing and maintenance. Regular testing of the DR plan is essential to ensure it works effectively and remains up to date with changing business needs and technologies. Employee training. Educating employees about the DR plan and their specific roles in recovery efforts is critical for a swift and efficient response to disruptions. Implementation tips. Documentation. Keep detailed and clear documentation for all procedures and recovery processes. Partnerships. Establish relationships with external services and vendors that can provide support during a disaster. Insurance. Consider business continuity insurance to help cover the costs associated with recovery from a disaster. Continuous improvement. Regularly review and update the recovery strategies and DRP based on lessons learned from tests and actual incidents. Disaster recovery planning is an ongoing process that helps safeguard an organization's operations against significant adverse events, ensuring stability and resilience in unexpected disruptions. This short video presentation on management and maintenance of secure networks provided a comprehensive and proactive approach to safeguarding critical network infrastructure and data. Key aspects include implementing robust network security policies, regular monitoring and auditing to detect and address vulnerabilities, and effective patch management to keep all systems up to date. Rigorous backup and disaster recovery plans are essential to prevent unauthorized access and minimize downtime during incidents. An effective incident response plan is necessary to address and mitigate the effects of security breaches quickly. Lastly, ongoing education and training for all network users are vital to maintaining security awareness and preparedness. This holistic strategy ensures network operations integrity, availability, and security in an increasingly complex cyber environment. Thank you for watching.